So, let's talk about serotonin. The first thing that probably pops into your head is the happy chemical, right? It's been branded as the simple key to our mood. But what if that whole story is just profoundly wrong?
The science today suggests serotonin's role is far bigger, way stranger, and much more fundamental than we've been led to believe. So, is it really just about happiness? Let's dig in and find out.
To really get to the bottom of this, we first have to appreciate what a deep biological mystery we're dealing with. Serotonin isn't some simple on-off switch for mood. It's a true enigma. I mean, just look at the sheer scope of what this one molecule touches. It's involved in aggression and sleep, your appetite and your ability to learn, sexual behavior and your body temperature. How can one thing be at the heart of so many different and, honestly, sometimes contradictory functions? And the mystery just keeps getting deeper when you look at its history. See, serotonin isn't new. It's an ancient molecule. We're talking over 1 billion years old, and you can find it everywhere, from plants to people. That tells you right away that its original job must be something incredibly basic, something fundamental to life itself, way more than just tweaking mood in humans. So, to figure out this ancient molecule's true purpose, we need to look at its architecture inside our brains. And let me tell you, its design is absolutely stunning. Just look at this map. This shows you the incredible scale of the system. All of these fibers, this vast brain-wide network, they all start from this teeny tiny collection of cells deep in the brainstem. It's like a single command center that has phone lines running to every single department in an entire country. And its reach is even broader than we used to think. It doesn't just talk to other neurons. The serotonin system communicates with glial cells. That's the brain's essential support staff. It talks to blood vessels and even the cells lining the fluid-filled parts of our brain. It is plugged into the brain's entire infrastructure. And all of this leads to one inescapable conclusion. This system isn't designed for quiet, one-to-one chats. No way. It's built to be a global broadcaster, sending out signals that can influence the state of the entire brain all at once.
Now, this broadcasting ability, that points to its real job, which is to solve a fundamental paradox of the brain. How does it manage to stay stable while also constantly changing?
This drive for stability has a name, homeostasis. It's the same process that keeps your body temperature stable or your blood sugar in check. And your brain needs this kind of stability too, just to function reliably day in and day out.
But here's the paradox, and it was captured beautifully by the physiologist W.B. Cannon nearly a century ago. True stability doesn't come from being rigid. It comes from being able to adapt and change. Right? The brain has to be able to learn, to rewire itself based on experience.
And here it is, the major plot twist. The serotonin system, the very system we thought was in charge of maintaining stability, is itself incredibly dynamic. It's not a fixed set of wires. It is highly plastic, constantly changing its own shape and size in response to what your body needs.
And you want proof? Look at this. On the top, you see serotonin neurons in a rat. Now look at the bottom. That's the same kind of neurons just 72 hours after the rat was given a stress hormone. The difference is staggering, an 80% increase in volume. The system physically grew in response to stress.
This remarkable plasticity, it reveals serotonin's true function. It's not just some simple messenger, it's the brain's master gardener. And this leads us to the absolute core idea of this whole explainer. Serotonin is what scientists call a trophic factor. And once you get this one concept, everything else just clicks into place. So what in the world is a trophic factor? Well, it's basically fertilizer for your brain cells. It's a substance that encourages your neurons to grow, to form connections, and to stay healthy. It literally tends to the garden of your mind, making sure the whole neural landscape is lush and well-maintained.
This image shows you exactly what that means. When there's plenty of serotonin, neurons are mature and complex, kind of like a thriving plant. But if you take that serotonin away, those same neurons start to wither, losing their branches and reverting to a much less functional state.
So this is its true purpose. Serotonin's main job isn't making you happy from one second to the next. Its job is to maintain the physical health, the structure, and the stability of your brain tissue over the long term.
Now, this new perspective of serotonin as a brain gardener completely changes how we should be thinking about mental health and the drugs we use to treat it.
For one, it finally helps us answer a really common question. If you take an SSRI antidepressant,
It raises serotonin levels in your brain almost immediately. So why does it take 4 to 6 weeks to actually feel better?
The old idea was like you were slowly refilling a happiness tank. It never quite made sense. But the new idea? It fits perfectly. The drugs aren't just topping up a chemical, they're facilitating a slow process of structural repair. It takes weeks because growing and rewiring brain circuits, that takes time. Just like tending a real garden.
So, in the end, it all connects. The incredible plasticity of this serotonin system is what allows our brain structure to be maintained and adapted. This physical adaptability is the very foundation of our psychological ability to respond to the world around us. And this brings us to a final and pretty critical question. This is a billion-year-old system designed for stability and slow structural adaptation. So what happens when this ancient brain gardener is suddenly confronted with the chronic stress and rapid-fire demands of our modern world?